Hello data friends, my name is Kamil and this is another episode of Microsoft Fabric series. This episode is about data science. Data science is a combination of mathematics, statistics and computer engineering. In Microsoft Fabric, data scientists can manage data, notebooks, experiments and models while easily accessing data from across the organization and collaborating with their fellow data professionals. In this lab, we will ingest the data, explore the data in a notebook, process the data with the Data Wrangler and train two types of models. By performing all these steps, you will be able to explore the data science features in Microsoft Fabric. By completing this lab, you will gain hands-on experience in Microsoft Learning and model tracking and learn how to work with notebooks, Data Wrangler, experiments and models in Microsoft Fabric. Let's jump in. When we open Microsoft Fabric, this is the landing page that we'll see. If you are not here, you can click always in here, Microsoft Fabric. Now I'm selecting this Synapse Data Science because this is kind of work we'll be doing today. So let me click on that and let's create the first notebook and the only notebook today. So this is the first cell that we have, but let me change this data science in Microsoft Fabric. Okay, this is our first cell. Now we have this notebook ready, so we are going to add the data and load the data to it. Now we are ready to run code to get data and train a model. We will work with the diabetes dataset from the Azure Open Datasets. After loading the data, we will convert them to a pandas data frame, a common structure for working with data in rows and columns. Now let's add new cell by clicking this plus code here. We have new cell and let me copy paste this code here and we'll be able to load the data. So there's some variables here, the storage name, container, relative pattern, etc. This code actually will load the data from Parquet file located in this storage. So let's run this cell right now. And after a few seconds, we'll have our data in this data frame. Okay. Now when our code is already executed, after 11 seconds, we can add another line, another cell, and display the content of this data frame. So let's see what we've got. And this is our data. Okay, we have few columns here: age, sex, BMI, BP, S1, S2, and etc. and column Y at the end. So let's review this. Here you can, this is how you can review it. And on top of that, you have two icons, table and chart. Right now, I will choose this chart and we will customize this chart by selecting box plot, removing this key, and that's, and here selecting Y column, apply, and this is our chart. Now that we have ingested and explored the data, we can transform the data. You can either run code in a notebook or use the Data Wrangler to generate code for you. The data is loaded into the Spark data frame. While the Data Wrangler is accept actually either Spark data frame and Pandas data frames, it's actually currently optimized for Pandas. So therefore we'll transform or convert this data frame, Spark data frame, to Pandas data frame. So let's run the following code. Let me add new cell and convert this data frame to Pandas. And we can actually show what is in this data frame. Now, the Data Wrangler is here on the top, so if we click this, then the tool is looking for any data frames. So now we have the only one data frame, which is called df. Let's select this, and the Data Wrangler tool is open and loading, profiling the data. Yeah. So on the right hand side, you will see the summary panel, where we have basic information about this data frame. And here we have columns and the statistics of these columns and their data. And also you can see here the histogram of this of the values of this column. So let's take a look on the while column. Currently the label column is y, which is continuous variable. To train a machine learning model that predicts y, you need to train the regression model. The predicted values of y might be difficult to interpret. Instead, we could explore training a classification model which predicts whether someone is low risk or high risk of developing diabetes. To be able to train a classification model, you need to create a binary label column based on the values from y. So let's select y here, column in the Data Wrangler. Note that there's a decrease in frequency for the 220-240. So this is the 220-240, this part, yeah. The 75th percentile is 211.5, roughly aligns with the transition of the two regions in the histogram. So let's use this value as a threshold for low and high risk. Navigate to operations on the left hand side, expand formulas, and then select create column from formula. Okay. Then the column name would be risk, and the formula would be like this: df from y, and the value in the 75th percentile, and as type int. Let's review the column. This is the new column that we are adding right now, mean 0, max 1. And when we scroll down, it's roughly about 25% of the values of our rows should be 1. And this is probably looks like a true, yeah? So now we can select apply here and add the code to the notebook. So now we have the code is here. Now we can actually add this code to the notebook by clicking this. Let's scroll down. And this is our code added from Data Wrangler. Let's add another cell here to just run describe function to just show statistics for if clean, because I need to run this cell, of course, first, then we can run this one. So just see statistics and information about this table, this data frame. And we can see the details about risk column that we just calculated. We have the data prepared, and now you can use it to train a machine learning model to predict diabetes. We can train two different types of models with our dataset. A regression model predicting Y, or a classification model predicting risk. You will be trained the models using the scikit-learn library and track the models with MLflow. Now let's run this code to split the data into the training and test dataset, and to separate the features from the label Y that we want to predict. And let's another cell and run this cell as well. This code creates ML flow experiment named diabetes regression, as you can see here. So our models will be tracked in this experiment. Let's add another cell and run it here. This code trains the regression model using linear regression. Parameters, metrics, and artifacts are automatically logged with MLflow. Now let's train a classification model. So let me add new cell here and copy paste this code, run this. So again, we are splitting data into the training and test data sets and separate the features from the label risk this time that we want to predict. So the code is executed. Another cell, let's create, copy and paste here. So this time experiment name is diabetes classification, and also this model will be tracked in this experiment. And let's add another cell here. So this code this time trains the classification model using logistic regression. Microsoft Fabric will keep of all your experiments and allow you to visually explore them. Now where we can find the experiments that we just created? Well, you can go to the workspace, clicking on the hub menu on the left, and then your experiments should be here. If you can see them, sometimes maybe they are not showing immediately, so try to refresh the browser, or you always can click the link in the experiment name here, clicking on the experiment link. So let me click first on the diabetes regression here, and we can review the run metrics here to explore accuracy of this regression model. Now let's go back to the notebook and click, or actually maybe here, and click the other experiment, this time diabetes classification, which is this one, and also explore the accuracy of classification model looking at the run metrics. Note that the type of metrics are different as we train different type of model. After comparing machine learning models that we have trained across experiments, we can choose the best performing model. To use the best performing model, save the model and use it to generate predictions. Select Save as ML Model on the top ribbon. Create new ML model, select folder Model, and let's name it Model Diabetes. And click Save. When it's safe, we can click this link View ML Model from the notification, and our model is loaded in this window. At the end, let's save our notebook, rename it actually, and so train and compare models. That would be my notebook. Actually, I can put name like lab08 at the beginning, and if I go to my workspace, I can move all those things to my new folder, which I create just before in here, lab08. Let me create this and move all these objects to the new folder to keep this environment and this workspace tidy. Microsoft Fabric offers one central workspace to perform data science from beginning to the end. To perform data science, you need to first define the problem. Then you can identify the data you need and ingest it into Microsoft Fabric. When you have ingested your data, you can explore and prepare your data using notebooks or the Data Wrangler. To train machine learning models as part of your data science project, you can track your work with experiments. And this is what we have learned during this video. Thank you very much for watching. That's it for today, and I hope you will see in the next video. And as always, if you want to learn more about Microsoft Fabric, visit Microsoft Fabric community website, which is phenomenal knowledge hub for this product. Meanwhile, have a wonderful day and see you soon. Bye!